All right, ready to dive into some cutting-edge 3D modeling today.
Always.
We're talking about NeRF, neural radiance fields.
Cool.
Ever imagine making like a crazy detailed 3D model
Yeah.
from just a few photos?
Oh, wow.
That's NeRF.
Really changes how we see virtual spaces, huh?
It's like,
I've always been fascinated by how NeRF just kind of
yeah,
ditches that old way of building 3D models piece by piece.
right.
It's more like teaching a computer to see the world the way we do.
Like it understands how light works and everything.
And then, bam, recreates it super accurately.
Kind of magical.
Yeah.
But here's the catch.
Oh.
Traditional NeRFs, they're resource hogs. Big time.
Ah, I see.
They gobble up tons of images, need serious processing power.
Yeah, that makes sense.
Not exactly something you can use every day.
Not if you're trying to make a quick 3D model from vacation pics, that's for sure.
You'll be waiting forever.
Uh-huh. Yeah.
And that's a big obstacle, right?
Huge. Making NeRF practical. I mean,
For everyone.
exactly. A lot of solutions now, they try to cheat a bit.
How so?
Using extra data sets or pre-trained models.
Like giving the AI a cheat sheet.
Totally. For example, you might have a separate AI just guessing the depth of objects.
Ah,
But that can introduce bias, make the process,
Yeah.
dependent on resources you might not even have.
So then how do we make NeRF faster and more efficient without sacrificing quality?
The million-dollar question.
Well, that's where our deep dive takes us today.
Phew, exciting.
To this paper on FrugalNeRF.
Okay.
Title's a bit of a mouthful.
Haha.
FrugalNeRF. Fast convergence for few-shot novel view synthesis without learned priors.
Catchy.
But the idea is so cool.
I'm all ears.
It's by Chin-Yang Lin, Chun-Ho Wu, and a team from National Yang-Ming Chiao-Tung University
Okay.
and NVIDIA Research.
Nice. The frugal aspect, that really jumped out at me.
Right.
Like, they get it. Not everyone has a supercomputer just lying around.
Exactly. And their solution, super ingenious.
Let's hear it.
So instead of those extra depth models,
Yeah.
FrugalNeRF uses what's called weight-sharing multi-scale voxels.
Weight-sharing multi-scale voxels.
Sounds like sci-fi, I know.
Uh-huh. A bit.
But think of it like
Yeah.
a digital Lego model.
Okay. I'm following.
FrugalNeRF uses different size blocks.
Okay.
Big ones for the overall shape, smaller ones for fine details.
That's the multi-scale part.
You got it.
Makes sense.
And weight sharing basically means it learns efficiently.
From those different size blocks.
Exactly.
I love that analogy.
Right.
It's like a painter using different brush sizes.
Oh, yeah, I see that.
Large ones for the background, then smaller ones for detail.
And FrugalNeRF does the same.
Starts broad, then gets finer as it goes.
That multi-scale approach is what nails that balance.
Between speed and detail.
You got it. And here's the real kicker, ready?
Hit me.
FrugalNeRF, it doesn't need those extra depth models.
Wait, really?
It figures out depth all by itself.
Wow.
Super clever trick.
So it has its own depth perception.
You could say that.
How does it do that?
Well, they call it cross-scale geometric adaptation.
Cross-scale geometric adaptation.
It's a self-check system, basically.
Okay.
So FrugalNeRF, it compares different resolutions of the 3D scene.
To the original pictures?
Yep. And it picks the resolution with the least error.
Clever.
Like solving a puzzle, finding the perfect fit.
Uh-huh.
That best fit becomes the pseudo-ground truth.
Meaning?
It guides depth estimation, no extra data needed.
That is super cool.
It's like when you take a photo and you're like, wait, that doesn't look right.
I do that all the time.
FrugalNeRF is doing that constantly, refining its depth as it builds the model.
Amazing. So what does this all mean, like, benefit-wise?
Well, the research shows some serious gains.
Yeah.
First off, FrugalNeRF is way faster. A lot of existing methods, especially those relying on those pre-trained models.
Makes sense. But does it sacrifice quality for that speed?
That's the best part.
Yeah.
It doesn't. In fact, it often matches or even beats the quality of other methods,
No way.
especially when you only have a few starting images.
That few shot thing.
Right. That's what makes FrugalNeRF so impressive.
I'm starting to see why this is a big deal.
Oh, it is. This few-shot learning, it means you could make a really accurate 3D model
Yeah.
from just a handful of pictures.
Whoa.
Imagine, like,
Give me an example.
quickly mocking up designs
Okay.
or visualizing your vacation memories in 3D.
That would be amazing.
It's bringing the power of NeRF to everyday stuff.
Exactly. Working with limited data, that's key, right?
Absolutely.
Makes NeRF practical, accessible.
Oh, everyone.
And that's what FrugalNeRF is all about.
It's that bridge, you know,
Between the cutting edge research.
to real-world use.
Exactly. And to really see this in action,
Yeah.
check out figure 4 in the paper.
Okay.
It's the leaves scene. The comparison is amazing.
I was just looking at that.
It really shows how much detail FrugalNeRF can pick up.
With so few pictures.
Right. Especially compared to those other methods.
It really highlights how powerful this approach is.
For sure. Like, take sparse NeRF,
Yeah.
tends to get blurry, especially with limited images.
Okay, I see.
And then there's simple NeRF,
Right.
captures some details, but it often has weird artifacts.
Like what?
Like floaters or holes in the rendered image.
That's not good.
Yeah, not ideal. But FrugalNeRF,
FrugalNeRF is different.
it consistently delivers high-quality, realistic models.
Even with limited data.
Exactly. It's quite remarkable.
Okay, so we've talked about how FrugalNeRF uses this multi-scale approach.
Right.
And that self-check system to figure out depth.
Mm-hmm.
But what about those times when it has to,
Yeah.
generate views from angles it hasn't seen before?
Ah, good question. That gets to the heart of what makes FrugalNeRF so effective.
Like filling in the blanks.
Exactly. It's all about generalization.
Yeah.
Being able to accurately render the scene from any viewpoint.
Ones it wasn't trained on.
You got it. It's like, instead of just recreating the exact input images,
It's going deeper, understanding the 3D structure.
the geometry, how light interacts, all of that.
Not just memorizing, but understanding.
A perfect analogy. And this is crucial, especially when you have limited training data.
That few shot situation again.
Yep. To do this, FrugalNeRF incorporates those novel viewpoints into its training.
Interesting. How so?
Well, it samples them along a spiral trajectory.
A spiral.
Imagine a camera spiraling around an object.
Taking pictures from different angles.
Exactly. It's a clever way to expose the AI to a variety of viewpoints.
I see. So it's not getting stuck on just those specific training views.
Right. And this spiral trajectory, it has a couple of key benefits.
Okay, like what?
First, it helps prevent overfitting.
Overfitting, remind me.
It's like cramming for a test, memorizing answers without understanding the material.
You might pass the test, but you don't really get it.
Exactly. So this spiral trajectory, it's like forcing FrugalNeRF to study more effectively.
Uh-huh. I like that. So it learns a more robust, generalizable model.
You got it. And secondly, this trajectory ensures consistency across all viewpoints.
Meaning?
When you're moving around that virtual scene.
It's smooth, no weird jumps or glitches.
Precisely. Imagine a VR experience where things jump around.
Be terrible.
Right. Smoothness is key for a believable, immersive 3D experience.
Absolutely. Okay, so we focused a lot on the visuals.
Yeah.
The realism, the detail, all that.
Right.
But what about the actual geometry of the scene?
Good point.
How good is FrugalNeRF at capturing the shapes and positions of objects?
That's one of the biggest challenges in 3D modeling, actually.
Especially with these image-based techniques.
Because images are 2D, right? There's always some guesswork in reconstructing that 3D geometry.
So how do you go from flat images to a true 3D representation?
Well, some methods use extra information, like depth maps.
To help them out.
Exactly. Some NeRF methods rely on those pre-trained depth models.
That we talked about before.
Yeah, but FrugalNeRF doesn't do that.
Right. It figures out depth all on its own.
And that's what makes it so impressive. It's basically forced to learn depth just from those images.
That's incredible. But how? How does it extract that depth information from flat pictures?
It all comes back to that cross-scale geometric adaptation.
The self-check system.
Right. By comparing different resolutions to the original images, it refines its understanding of the geometry.
So it's constantly checking, making sure things make sense.
Exactly. It's asking itself, does this match what I see in the real world?
And through that process, it builds a really accurate 3D model.
Even without those explicit depth measurements.
That's wild. So even though it's faster, more efficient,
it doesn't skimp on the accuracy.
amazing.
And the researchers, they actually tested this.
Yeah.
Using the DTU dataset.
What's that?
It's designed specifically to test geometric accuracy in 3D models.
Oh, I see.
And FrugalNeRF, it aced it. State-of-the-art results.
So it's really a win-win.
It seems that way.
Yeah.
Faster, more efficient.
But no compromise on quality or accuracy.
And that's the potential here.
To revolutionize 3D modeling, make it accessible.
To everyone, it's exciting to think about the possibilities.
Like what? Give me some examples.
Well, imagine creating a 3D model of your home.
Just from a few phone pictures.
Exactly. Or scanning a product prototype.
To see it from every angle.
Right. Or how about lifelike 3D avatars for games?
That would be awesome.
The applications are endless.
This is seriously blowing my mind.
It's a game changer. This technology could totally reshape how we interact with the digital world.
It's like bringing 3D modeling to the masses.
Exactly. It's not just for professionals anymore.
This is so cool. But,
Yeah.
we've been praising FrugalNeRF a lot.
Right.
Are there any, downsides?
Good point. No technology is perfect.
True.
And FrugalNeRF does have a few limitations.
Okay. Like what?
One key thing is it still needs accurate camera poses.
Camera poses
It means the position and orientation of the camera.
for each photo.
Exactly. It's like telling the AI where you were standing, which way you were pointing the camera.
Giving it context.
Precisely. And
Yeah.
this is usually figured out through camera calibration.
So if that information is off,
Things can get messy.
how so?
The 3D model might be distorted, objects in the wrong places.
It wouldn't look realistic.
Right, it's like a jigsaw puzzle with warped pieces.
So how do you avoid that?
You can use a really robust camera calibration method.
To get those poses as accurate as possible.
Right, or use more input images.
To compensate for any errors?
Exactly. It's a trade-off.
More accurate poses? Fewer pictures?
But if the poses are uncertain, more pictures help.
I see. Makes sense.
And sometimes getting accurate poses is just really difficult.
Like when?
Imagine a drone taking pictures or a moving vehicle.
The camera's always changing position.
Exactly. Hard to pinpoint those poses accurately.
So FrugalNeRF might not be the best for every situation.
Right, especially if those camera poses are tricky.
There might be other methods better suited for those scenarios.
Exactly, but for a lot of applications where the scene is relatively still,
And you can get those accurate camera poses.
FrugalNeRF is a fantastic choice.
It really seems like it.
It's an amazing piece of technology.
It could really change how we do 3D modeling.
Absolutely. I'm curious to see how this technology evolves.
Me too. But before we get ahead ourselves, one more thing.
Okay, what's that?
We've talked about the benefits, the limitations,
Uh-huh.
but what about the big picture? How might FrugalNeRF impact our everyday lives?
I think one of the most exciting things is
Yeah.
it's this potential to,
Yeah.
democratize 3D modeling.
Democratize meaning?
Like, make it available for everyone. Because traditionally, to make those really realistic 3D models,
yeah.
you'd need,
Oh.
special software, powerful computers, lots of expertise.
So it was expensive and complicated.
Exactly. It was pretty much a field for professionals,
Reserved for the experts.
Yeah, exactly. But now, with tech, like FrugalNeRF,
Things are changing.
we're seeing that barrier breakdown.
So now anyone can make these incredible 3D models.
Yeah, potentially anyone with a smartphone or a camera.
Wow, that's pretty amazing.
It really opens up the possibilities.
Like, give me an example.
Sure. Imagine scanning your living room,
Okay.
and then you can play around with different furniture arrangement.
In a virtual copy of your living room.
Exactly. Or how about capturing a 3D model of, say, a historical artifact
Yeah.
and sharing that with people around the world?
That would be incredible.
Right. Those are just a few examples.
Yeah.
Think about creating personalized 3D avatars for games or online worlds.
The possibilities really are endless.
They are. This could revolutionize how we interact with,
What?
the digital world.
This is blowing my mind. It's like taking something super complex and technical
Yeah.
and making it accessible for everyone.
Exactly. And this is really just the beginning.
You think so?
Oh, absolutely.
Yeah.
As these technologies get better, more accessible, we're going to see an explosion of creativity, new ways of using 3D models.
Oh, I can't wait to see what people come up with.
It's going to be incredible.
But, we've been focusing on the positives.
Yeah,
Are there any downsides to FrugalNeRF?
that's a good question. I mean, no technology is perfect, right?
Chris?
FrugalNeRF does have some limitations.
Like what?
One key thing is it still needs accurate camera poses for those input images.
Camera poses.
So that's basically the position and orientation of the camera for each photo.
Like where you were standing when you took the picture.
Exactly. And which direction the camera was pointing.
So if that information is wrong.
It can mess things up.
Oh,
Well, the 3D model might end up distorted.
okay.
Things might be in the wrong place. Shapes might be skewed.
It wouldn't look very realistic.
Yeah, not so much.
So how do you make sure you have accurate camera poses?
Well, you can use a robust camera calibration method.
To get those poses as precise as possible.
Exactly. Or you can use more input images.
To help compensate for any errors.
Right, so it's kind of a trade-off. More accurate poses, fewer images needed.
And if the poses aren't so accurate, more images can help.
Exactly. And sometimes getting accurate poses is really hard.
Wow.
Imagine a drone taking pictures, or a moving vehicle.
The camera's moving all over the place.
Exactly.
Yep.
It's tough to get those poses right in those situations.
So for those cases, FrugalNeRF might not be the best tool.
That's right. There are other methods better suited for those situations.
Makes sense.
But for a lot of other applications, when the scene is fairly still.
And you can get those accurate camera poses.
FrugalNeRF is a fantastic choice.
It really does sound like it.
It's a groundbreaking piece of technology.
It could really change the world of 3D modeling.
Absolutely. And it's so exciting to see research like this pushing the boundaries, opening up possibilities.
I totally agree. So to wrap things up,
Yes.
for anyone listening who wants to learn more about FrugalNeRF,
Yeah.
we'll have links to the paper and the website in the show notes.
Check those out. Some really cool stuff there.
All right, thanks for joining us for this deep dive into FrugalNeRF.
It's been a pleasure.
Until next time.